Okay, today's date is October 17th, 2019. This is a 9-question review of grade 9 work so far covered in this year. The first 6 questions are questions that are from Chapter 2 on rational numbers. The first one says, what's negative 1 1/2 plus 2 3/5? So when you are adding or subtracting rational numbers in fraction form, just like we did in grade 7, the easiest way to do it is to convert them into improper. So the first step I'm going to do is change those mixed fractions into improper. And because it's a negative 1 1/2, I'm going to keep that negative symbol in the numerator because it just keeps it easier for me to kind of keep track of it. Next thing I'm going to do is find equivalent fractions that have the same denominator. In this case, I'm going to use 10. I'm going to use negative 15 tenths as an equivalent fraction to 1 1/2. And I'm going to use 26 over 10 as an equivalent fraction to 13/5. And this next step is one that most people forget to write, and as a result, they usually get the wrong answer. But your next step is to add the numerators and keep the denominator. And negative 15 plus a positive 26 is going to be a negative 11 over 10. So your answer as an improper fraction is, positive, not negative. Positive 11 tenths, which as a mixed fraction is 1 1/10. Okay, so your answer is 1 1/10. The second question asks you to solve it without using a calculator. If I was putting it into context, I would probably think of it as being I owe $1.20, but I have $3.40. I'm going to think about money when I can. If I was combining $1.20 worth of debt with $3.40 that I had, I'm going to pay off all of my debt, and I'm going to still have $2.20 left over. So your answer is 2.2. How I would get that is I would take the one I have the most of, in this case positives, and I would subtract the one I had less of. And when I did that, I would still get my answer of positive 2.2. Okay. Think about money anytime you can, because money is the one number thing that we all probably understand the best. In the second question, I don't like to think of subtraction, so I told you before that if you use the addition rule where you change the subtraction to addition, use the opposite integer for the second, you can add them instead and get the same answer. If I owe $1.20 and I owe $3.40, all I have is debt. I can't pay anything off. I'm going to combine my debt together. I'm not going to worry about negatives because I know it's going to be negative. Combine all my debt. See how much debt in total I have. In total, I would owe $4.60. Continuing along. The fourth question says, what is the square root of 1 and 40 81sts, I guess, or 40 over 81? And we learned that if you're going to find the square root of a rational number that's a mixed fraction, the easiest way to do it is to change your mixed fraction into an improper. So this would be 121 over 81. So the same question would be, what's the square root of 121 over 81? Meaning, what fraction multiplied by itself is 121 over 81? Well, both the numerator and denominator are perfect squares. The numerator will be 11. The denominator will be 9. And therefore, the square root is 11/9 as an improper fraction. Or as a mixed fraction would be 1 and 2/9. So your answer is 1 and 2/9 is the square root of 1 and 40 81sts. Or what's the square root of 121 over 81? Same question. As an improper fraction, the answer would be 11/9. Question 5 says, what's the whole number with a square root between 6 and 7? Well, what number has a square root of 6? The answer is 36. What number has a square root of 7? The answer is 49. So therefore, any number, any whole number, the square root of 37, for example, would have a square root of 6 decimal something, etc., all the way up to the square root. The last square root number would be the square root of 48. So any whole number, 37, 38, 39, ... all the way up to 48, those are whole numbers. You can have any of those answers whose square root would be between 6 and 7. So anything from 37 to 48 is a correct answer. The next question says, estimate the square root of 0.83. So I gave you the hint that 0.64, the square root of that is 0.8. So therefore, you were to infer that the square root of 0.81 is 0.9. That's going to be one of my benchmarks here for 0.9. And the square root of 1 is 1. So the square root of 0.83 on my number line would exist somewhere around, I don't know, here, and therefore is about 0.91 or 0.92, or maybe even, I don't even know, but 0.93. It's one of those three. Double check with a calculator. What is the square root of 0.8? You weren't supposed to use a calculator though, were you? Square root 0.91 is approximately. So we were right with our first guess, 0.91. It is true. Okay. Question number 7 is now a part of our chapter 3 on exponential form and power. And the seventh question said -3 multiplied by, in brackets, -2 exponent 2. So, first thing I need to remind you is that this is the same thing as this, and that this is not the same thing as this, right? The brackets are there. The only reason there's brackets here is because it wants to show multiplication, okay? So technically, I could have rewritten this question, and instead of using brackets, I could have said -3 multiplied by -2 squared. This is the same thing, right? First thing I would do would be my exponents. This is not -2 times -2. That's the opposite of 2 squared. The opposite of 2 squared is -4. And -3 times -4 is a +12. So your answer for that question is +12. And I'll show you using the regular way here. So my next step should be -3 multiplied by the opposite of 2 squared, which is -4. And a -3 times a -4 is a +12. My next question says -2 multiplied by 5 to the exponent of 0. Take away, in brackets, -2 cubed. So if I do my exponents first, it's going to be -2 multiplied by any base to the exponent of 0 is 1. Take away. Now, because the brackets are around -2, that is defining the base as being -2. So that would be -2 multiplied by -2 multiplied by -2, which is going to be a -8, which I'm going to keep in brackets because this subtraction sign still has to exist. And this power is simplified in standard form to -8, so I need to separate a subtraction symbol from a negative symbol using brackets. Now I've done my exponents, I'm going to do my multiplications next. -2 times 1 is -2. I have this next. Now all I have is a subtraction, which is going to be keep, flip, change. -2 and 8 gives me a +6 as a solution. And your last question is question number 9, and it says 10 multiplied by 2 squared cubed minus 3 to the 1. So if I solve this, remember, I'll do this down here for a second. When you have a power to an exponent, the rule is keep the base and multiply the exponents. So technically, that is in exponential form 2 to the 6. Okay? So when I think of it as a power, I could simply read this as 2 to the 6. Now, if I want to write it like that, I can. Okay, so all I did was I simplified my power. And now I have to think about what's 2 to the 6? Well, it's 2, 4, 8, 16, 32, 64. So it should be 10 times 64 minus any number or any base to an exponent of 1 is itself. So that's going to be -3. 10 times 64 is 640. And finally, 640 take away 3, which is your last step, is 637.